condensation polymerization. This is the second type of mode of polymerization, which is also called step growth polymerization. Why it is called step growth polymerization? The reason is because, now let us take an example to explain this. The polymer taken is nylon 6X. See, it's a copolymer of hexamethylene diamine and adipic acid. Both having 6 carbon atoms. Now, these two molecules, how they combine, the OH of this and the H of this goes out. So, minus water will give us this monomer which is having an acid group on one side and NH2 group on the other side. Now, this monomer will combine with the same type of monomers from this side as well as on the other side. This is called N side and this is called C side, and this is how they form a long chain. So, OH goes out here, H goes out here. So, N number of water molecules are lost, and at the end what we have is this polymer, which is called nylon 6X. Now, what is most important to note in this case is why it's called step growth, because in this always the bifunctional monomers combines with each other across the functional groups with the loss of small molecules. Now, as the monomer formed is chemically different from the combining molecular species, every time the monomer is formed is chemically different, and that's why it's called, and then they join, that's why it's called step growth. See, here we were having acid and amine, but the functional group formed between them is an amide. So, amide is having no as such a link with these two. So, that's why amides again combines to form amides. So, this is how the stepwise these monomers combines with each other, and it's called step growth polymerization. In these, therefore, the monomers are never resembling its constituting molecular species, because the loss of molecules takes place and the functional groups gets changed. Now, these condensation polymerization or these condensation polymers can be classified into many types depending upon the functional group which is present between the monomers or the functional group which is joining them. Like in this case, the functional group which is joining the monomers is an amide linkage. That is why the first example of the step growth polymerization of polymers we can take is your examples I am giving you are polyamides. Now, what are polyamides? Polyamides are those polymers in which the monomers are joined to or linked to each other through an amide linkage. That is why they are called polyamides. Nylon 6,6, which we have just done, is the best example of polyamide. There is one more example which is called nylon 6. Yes, it's only 6. It's a homopolymer. It starts from caprolactam. So, it's a 7-membered ring, heterocyclic ring, which is called caprolactam. This at around 533 Kelvin in presence of the acidic medium, what happens is it breaks down from here, and what we find during its hydrolysis, of course, what we find is that it opens up, and what we get at the end is this CH2 5 carbons 1, 2, 3, 4, 5. So, we can number them here 1, 2, 3, 4, 5, and sixth one is the own original carbonyl group. So, this is how we have this monomer which combines again with each other through amide linkages. So, it's a homopolymer of caprolactam, and the polymer formed is nylon, but since its monomer is having only 6 carbon atoms, it's called nylon 6. So, these are polyamides. This nylon 6 is basically used in making tire ropes, tire cords, ropes and your fabrics. And then the second category of the condensational polymer we have are called polyesters. Polyesters. So as the name indicates, the functional group which links the monomer units are esters. The best example we can give you is Decaron, which is also called terylene. Now how it is formed? It's a copolymer of ethylene glycol and tarphalic acid. So it's basically, which is also called benzene 1,4-dicarboxylic acid. So it's a copolymer between these two molecular species. What happens is OH of this and H of this goes out. From here the H goes out, from here the OH goes out. The H goes out from here. So what we have is n number of water molecules are lost. So what we get is CH2, CH2. This is the ester linkage we are having. So this is what we have, your terylene. Now terylene is basically is used in making fibers which are blended with your cotton and wool and others to make clothes and fabrics, other types of fabrics. Now terylene, this reaction is basically takes place from 420 to 460 Kelvin temperature, and it is being catalyzed by zinc acetate plus antimony trioxide. So this is how we get terylene or Decaron, which is a polyester condensation polymer. The third type of example of condensation polymers is the phenol formaldehyde, which is also called Bacolite. See, Bacolite is formed between the reaction of phenol and formaldehyde. When these two are reacted in either acidic or basic medium, ortho para or all tri substitutions takes place. We get CH2OH at ortho with respect to phenol, or at para, and also at all the three positions. So all these three products are formed. Now when these products are subjected to acidic medium, they form a long chain in which one phenol molecule gets attached to the other one through these CH2 bond, the CH2 linkages. Now this linear polymer chain is called Novolac. It is the one which is being used in the paints. Now this is a resin form, this is in semi-fluid state, Novolac. On this Novolac on chemically treated, a lot of cross linkages develop between these chains like this, from here and from here like this. So what happens is a complete network structure is formed, cross-linked structure is formed, which is called Bacolite. Now this is the Bacolite which is used in making your electrical switches, the handles of various utensils, like we have pressure cookers and others, because it's very much resistant to heat, and it is also in making your pornography discs, like other sort of strong things. So it's a very important cross-linked polymer which is nowadays very commonly and widely used. The other type of example of copolymer and condensation polymer is the melamine formaldehyde polymer. It's the same polymer which is used in making unbreakable crockeries. Now it is made up of melamine molecule and a formaldehyde. When both of these combine, this kind of a monomer is formed, which is actually having a CH2OH bond, like a species linked to the NH2 group, which has now turned into an NH group. Now we have two more NH2 groups left out. So still when more of the formaldehyde is reacted, the same CH2 group OH is getting attached here also and from here also. And when this type of monomers from all these three sites are allowed to go through for polymerization, three-dimensional cross-linked structure is formed, from where what we find is this NH group through a CH2 group is linked to all these similar type of molecular species from all the three sites. And this gives this melamine formaldehyde polymer a three-dimensional complex network structure, due to which it becomes unbreakable. And that is why it is used in making unbreakable crockeries and a lot of other things, useful daily routine household useful things.